In this lesson, we're going to look at the last rule of indices. Now, this rule of indices is rule 6, and it helps us deal with powers that are fractions. So you can see up here that there's some fractions listed out. I'll just go through the top ones first. If we're trying to deal with the power of a half, I'll show you why this works in a second, but for just now, a to the power half is just the square root. So for example, if I said what's 9 to the power of a half, you might be thinking, I don't know, but if we understand that the power of a half is exactly the same as the square root, we can now square root 9. Square root of 9 is 3. So 9 to the power of a half is just 3. Now, if you take something to the power of a third, then that's the cube root. That means what times what times what gives that answer. So for example, the cube root of 8 is 2, because 2 times 2 times 2 makes 8. So 8 to the power of a third is also 2. And the last one here, a to the power of a quarter, is the fourth root. What times what times what times what makes that answer? An example would be 16. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 makes 16. So 16 to the power of a quarter is 2. Now the same thing happens with a fifth. It's the fifth root, and 6 is the sixth root, and so on. Now, fractions don't always have a 1 in the top, so what do we do when we have a number in the top? Well, the bottom part in this first example stays as the root, and the top bit goes as a power. Same idea in the second example here. We're still doing the third root, but we're doing it to the power of 5. So a to the power of 5 over 3 is a cube root of a to the power of 5. A to the power of 9 over 4 is the fourth root of a, and you take it to the power of 9. Again, I'll show you why in a second. Okay, so for any value, if you're taking it to a fractional index or power, the top bit is the power and the bottom bit is always the root. It always works out like that. And once you get it in this format here, with the root and the power, you can actually work it out with numbers. Again, we'll look at that in the next lesson. Okay, so let's look at why this works. Well, let's look at this first example here. This one over here. So we've got a to the power of half times a to the power of a half. If you look at that first, then what do you do when you times indices? Well, you add them. So a half plus a half gives you 1. So a to the power of 1 is just a. Now, if you split a up into two things that multiply together to make it, then really the only way to do that is to think, well, okay, if you take 100 for example and you try and split that up to two things exactly the same, but times to give the answer, well, that'd be 10, wouldn't it? 10 times 10 makes 100. And what relationship does 10 have to the 100? It's the square root. You could do this with 36, another example. So say you're starting with 36, well, if you break it into two things that are exactly the same, that when multiplied give you 36, well, that must be 6. So each one of these things, a to the power of half, must be 6. What's the relationship between 6 and 36? It's the square root. So from that we can see that a to the power of half must be the square root of whatever this number is here. Let's look at a third. So a to the power of third times a to the power of third times a to the power of third. What do you do when you times indices? You add them. So a third plus a third plus a third gives you 1. So a to the power of 1 is just a. So if we're trying to think of a number and we're splitting it into three things exactly the same that multiply to give that number, for example 8, these all must be 2. What relationship does 2 have to 8? Well, it's the cube root. So we can say that a to the power of third is exactly the same as the cube root. This idea works for the fourth root and the fifth root and so on. Okay, now let's look at what happens with this idea here, the cube root of a squared. So we know from that last wee section that the cube root of a is a to the power of a third. Now if you square a to the power of a third, you have that. What do you do with powers when you times them? You add them together. So what's a third plus a third? It's 2/3. So these things are exactly the same. The top number is the power, the bottom number is the root. So we can say that a to the power of 2/3 is the cube root of a squared. Okay, I'll show you that just one more time. We've got the square root of a cubed. We can rewrite the square root of a as a to the power of a half. Now if we're cubing that, times it by itself, and then times it by itself again. When you're multiplying indices, what do you do with the powers? Well, a half plus a half plus a half, that's 3 halves. So these two things are exactly the same. Bottom number root, top number power. So a to the 3 over 2 is the square root of a cubed. Okay, so an easy way to remember it is the root always goes in the bottom. That's the way I remember it. So the root here, here, it always goes in the bottom. The square roots are 2, so it goes in the bottom. Cube root, 3 in the bottom. Then the power will have to go in the top.